alkaline potassium permanganate, which oxidizes the iodide to iodate. The transition metal exhibits variable oxidation state in a compound. This is due to the availability of both Ns and N-1 d orbital to form a bond. Interstitial compounds are those which are formed when smaller atoms like a carbon, hydrogen and nitrogen are trapped inside the crystal lattice of the metal. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in this session we are going to start with one more unit, that is Unit 8 D and F block elements. So let us understand, so what is all about the D and F block elements. So in this chapter, we are going to study the usual and unusual behavior or the properties of D block elements and the classification of the blocks based upon their characteristic property. During the filling of electron, the last electron will decide the block of that elements. So whenever we added the electrons, the last electrons, will decide what is that elements belonging to which group. Okay, and D block elements consists of or contains the groups from 3 to 12, and the numbers of the compounds of these blocks are important catalysts in our industries. Okay, so they are mainly act as what? Catalysts. You can see that I have placed only the D blocks. It is started from group 3 to group 12, and the elements are go like this, like scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, as well as with the zinc. And you can see that the elements from group 3, you can see that the element with the atomic number 57 has suddenly changed to 72. Next element is 72. Why is that sudden change in the or sudden increment in the atomic number? That is mainly because from the atomic number 7 to 71, there is a set of 14 elements. They are similar with their chemical property as well as their physical property. Hence, they have placed below in the periodic table, and hence it is named as what? Lanthanide series. They are named as what? Lanthanides. Okay. Similarly, you can see that atomic number 89 to 104, there is a sudden jump in the atomic number. That is also mainly because the elements from the atomic number 89 to 103, it has been placed below in the periodic table, that also consists of 14 sets of elements. They are also called as what? Actinides. Okay, you can see that the lanthanum elements or lanthanide series start from the lanthanum and ends with lutetium. Similarly, the actinium series start with actinium and ends with lauretium. Okay, this is how this full sets of elements are known as what? D block. Okay, this lanthanides and actinides together known as what? F block. It is also known as inner transition element also. Inner transition series or elements, whatever. Okay, but the D blocks are generally known as what? Transition elements. Why? Do you know why they are called as transition elements? Because they have placed in between the S and P block, hence they are called as what? Transition elements. Okay. We'll see with the pattern of question which has been repeatedly asked. We can expect 1 mark from this unit, that is from part 1, the question number 10. And in the part C, definitely we are going to get 3 questions, that is a question number 30, 31 and 32. So this unit which also carries the 10 marks, that is also maximum marks. We'll see with the 1 mark and the 3 mark question which has been asked from this unit. Okay. Name the 3D series of the elements which do not show the variable oxidation state. So as I said, the D block elements are the transition elements which has been placed in the S and P block. In between the S and P block, we have placed the D block, and hence that is known as transition elements, which usually shows the variable oxidation state. Since it is showing the variable oxidation state, we have to know the exceptional cases also. So we have few elements which doesn't show the variation in their oxidation state only. They are nothing but scandium, Okay. Name the 3D series of the metal which shows the higher oxidation state. So, the higher oxidation state shown by a 3D series of the transition element is manganese, that is +7. Okay. Name the metal in the 3D series of the transition metal which exhibits the +1 oxidation state frequently. So, copper is only the one which can frequently exhibits in a +1 oxidation state which is belonging to the 3D series. Okay. Next, name the alloy of the transition metal with the non-transition metal. So, the alloy of the transition metals are the example of the brass and bronze. Okay. So, it usually alloys are formed by mixing up of two metals. Okay. It may be metals or non-metals, whatever it may be. So, copper with the zinc and copper with the tin are some of the example which forms a brass and a bronze are the two types of alloys. What is the action of natural and faintly alkaline potassium permanganate solution in iodide? So, alkaline potassium permanganate which oxidizes the iodide to iodate. As we all know that potassium permanganate KMnO4 is an oxidizing agent. It is an oxidizing agent which oxidizes iodine to iodide. Okay. Next, or iodate. Zinc and cadmium and mercury of group 12 are not regarded as transition metal, and why? So, if you see the periodic table, you can call zinc, cadmium and mercury which is belonging to the group 12, zinc, cadmium and mercury. Even though it is belonging to the transition series or it is belonging to D block, generally they are not called as transition elements only. What is the reason behind it? That is also exceptional cases you have to know. Zinc, cadmium and mercury of the group 18 has filled, okay, which consists of full D10 configuration, which means to say that in the D block element, last electron should enter with the D block. Hence, they are known as what? D block only. Correct? No. But in zinc, cadmium and mercury, they have full completely filled electronic configuration because the d orbitals are completely filled in the ground state as well as in the common oxidation state. Hence, they are not called as what? Transition series or the transition metals only. Okay. This is the exceptional cases you must know for your competitive purpose as well as for the board exam. Next, transition metal exhibits variable oxidation state in its compound. What is the reason? The transition metal exhibits variable oxidation state in a compound. This is due to the availability of both Ns and N-1 d orbital to form a bond. So, as we know that in the D block element, if you take any of the example, okay, the last electrons are entered to the Ns first. Okay, then with the inner d orbital. So, we write the general configuration as N-1 into d. So, this N is an inertia. Towards the inertia, you are going to add the electron. So, that is why they are also called it as what? Transition series or the inner transition series we call. Okay. Given one use of mesh metal will be used in magnesium based alloy to produce a bullet, shells or with a lighter faint. Next, we will go with the 3-mark question. Mention any 3 consequences of lanthanide contraction, or they can ask you to write the differences between lanthanide and actinide contraction. So, or they can give you the differences between lanthanides and actinides also. Okay. So, what is the consequences for the lanthanide contraction? You must know that. So, the radii of the 3D series row transition series of the elements are almost similar to that of the second row transition series of the element, or with the because of the identical radii of the zirconium and hafnium, they shows the consequences, and the separation of lanthanides in the pure states has become very difficult. That is also another consequences which happens in the lanthanide. Next, what are lanthanide contraction? Mention the causes of lanthanide contraction. So, you must know what are the consequences, what is lanthanide contraction, what are the causes for this lanthanide contraction also you must know that. The overall decreasing in atomic radii or ionic radii from the lanthanum to lutetium, it is known as what? Lanthanide contraction. This has happened, that is mainly because They have a similar physical and chemical property. As I said, from lanthanum to lutetium. Okay, lanthanum to lutetium, they shows a similar physical and chemical property. Due to their similar physical and chemical properties, the atomic radius are completely going to be decreased, which makes the lanthanide contraction. What are interstitial compound? Give an example. Interstitial compounds are those which are formed when smaller atoms like a carbon, hydrogen and nitrogens are trapped inside the crystal lattice of the metal. So, if you take the iron or if you take the titanium, the smaller metal like a carbon, hydrogen and nitrogen can fit inside this metal. This is known as what? Formation of interstitial compound. Example, titanium carbon, you can see that manganese nitrogen and iron with the hydrogen. Next, between the titanium plus 4 and titanium plus 3, which one is more stable and why? So, it is quite interesting. You must know what is the reason behind it. Titanium plus 4 ion has noble electronic configuration, or you can see that the titanium has argon, okay, 18 electronic configuration, or you can say that titanium plus 4, it shows NS2 NP6, okay. It is completely filled. Because it is completely filled, titanium plus 4 is more stable than the plus 3. Next, transition elements shows catalytic property. Given example. In the beginning only I said the D block elements are the very good catalysts in the industries. They are well used in a different manner for the different kinds of reaction also. So that is mainly because of the variable oxidation state and the lower surface area for the adsorption and formation of the intermediate compounds. Next, very important one, that is manufacturing of potassium dichromate from chromite ore. Okay, this is another important reaction. You must know that. The one thing is, in the examination, no need of writing with explanation and all. If you balance the reaction and if you write it in a 3-step, you can easily get the 3 marks. And most of you, if you don't know, if you know how to write it with your own words, you can write it for the 3 steps to get a 3 marks. You can easily get the 3 marks from this unit. Okay, you have to know that what are the reagent that you are taking, what is the expected product you have to rate in a balanced manner. Okay. So, in the first step, what will happen, the chromite ore, that is FeCr2O4, is fused with sodium carbonate, that is Na2CO3. In presence of air, it forms sodium chromate with the formation of ferric oxide and carbon dioxide is released. In the second step, the sodium chromate is a yellow solution which is obtained above, which is acidified with sulfuric acid. Okay, the sodium chromate is a yellow solution which is acidified with the sulfuric acid, and to get an orange color of sodium dichromate, to get an orange solution of sodium dichromate, formation of sodium sulfate and water. The sodium dichromate, which is allowed to react with the sodium dichromate solution, is concentrated and cold, and it is less soluble with the sodium sulfate, so it will be crystallizes out. Third step, what we will do, we will take this sodium dichromate and now it is treated with KCl, potassium chloride. So we know that potassium can easily replace the sodium and forms a potassium dichromate with the formation of sodium chloride. This is how, in the 3 steps, you have to show that how do we prepare the potassium dichromate? By using chromite ore. By using chromite ore. It is a short question for your exam. Next, like that, one more preparations will be there. That is how a potassium permanganate is prepared from the manganese dioxide. Write an equation. So, potassium permanganate is prepared by the fusion of manganese dioxide with base. Okay. So, manganese dioxide we will take and we will fuse with a base in presence of an oxygen. It forms potassium magnetite. It forms what? Potassium magnetite with the formation of water. This potassium magnetite, it is later acidified with the water to form potassium magnetite, with a manganese dioxide and potassium sulfate and waters are released out. Okay. So here I have shown the two types of reaction. You can carry out any one of this reaction for your sake. And in the third step, manganese dioxide is fused with a base in presence of an oxygen to form a manganated ion, and a green color manganese oxide, which is allowed pass through the electrolytic oxidation with the alkaline medium, it forms purple color manganese oxide. So in laboratory, it is commercially done. In laboratory, the manganese plus 2 salts are obtained by oxidation of peroxodisulfide ion to form a potassium permanganate. So what we will do in laboratory, we will take the manganese oxide and which is allowed to treat oxidized with a peroxodisulfide bond, peroxodisulfide compound to get a manganese, and this is how we can write the reaction in the basic medium. So, or you can write the reaction in the acidic medium also to show that how potassium permanganate are prepared. So, this is all about the important questions which has been raised frequently many times in the D block. Remember, the differences between the lanthanide and actinides can also be asked, or the consequences of the actinide series, or causes of the actinide consequences, or what are actinide contraction also can be asked. Okay. So, hope you all understood with the session. I will come back with one more unit. Till that, take care and be safe. Thank you.